Welcome back to The Explainer. Today, we're diving into a literal game changer in systems architecture for autonomous coding agents. If you've been working with third-generation terminal native tools recently, you know things are moving fast. We've totally graduated from basic autocompletion. We're now dealing with highly capable agents that can plan out entire features, edit multiple files at once, and just execute terminal commands completely on their own. But with all this newfound autonomy comes a massive architectural headache that pretty much every engineering team is hitting right now.
So here's the million-dollar question we're all wrestling with. We obviously want our AI coding agents to be powerful, right? We want them plugged into our massive external systems, local databases, intricate issue trackers, complex cloud APIs, the whole shebang. But here is the friction. How exactly do you give them that level of enterprise access while keeping their active memory fast, clean, and actually capable of reasoning? How do we scale this out without just completely breaking the agent's brain?
Let's start by looking at the context bloat problem, which is basically what happens when an agent's memory turns to pure noise.
We all want a perfectly healthy context window for our agents, an environment with clean architectural intent, precise system boundaries, and plenty of room left over for the agent to use its cognitive budget to actually solve complex problems. But then reality hits. The old integration method inevitably leads to context bloat. When we start stuffing every available API schema, raw tool log, and messy custom wrapper directly into the prompt, the token buffer literally just suffocates. The model gets confused, performance falls off a cliff, and the agent completely loses track of your original instructions. Best case, it hallucinates. Worst case, it enters one of those infinite failure loops where it just burns through tokens trying to read an unparsable wall of text.
To put that into perspective, just look at this number, 191,300. That is exactly how many tokens of context you can save in a tool-heavy enterprise environment simply by not injecting full, raw JSON schemas directly into the initial system prompt. Before this new architectural shift, engineers were literally forcing their agents to memorize the entire structure of a database right out of the gate. That eats up hundreds of thousands of tokens before a single line of code is even written. Imagine getting almost 200,000 tokens of active cognitive bandwidth back for your agent to actually think with.
Which brings us to the solution, introducing the Model Context Protocol, the blueprint for modularity.
To fix this massive context decay, the industry is rapidly shifting to an incredible new standard called the Model Context Protocol, or MCP. It basically acts as the ultimate bridge by completely separating the AI reasoning model from the external tools it's trying to use. It operates on this beautifully clean client-server architecture. Your agent is the client, and it connects effortlessly to external MCP servers. The huge win here is that the language model is no longer burdened with upfront memorization. It doesn't have to learn the entire API surface of your enterprise stack. It just needs to know how to speak the protocol.
Let's look at the Universal Power Plug, which is hands down the best way to visualize this client-server modularity. Think about hardware for a second. Imagine your CLI agent is holding just one standardized universal power plug. If you're a developer, you know the absolute nightmare of the past. Connecting an agent to 5 different enterprise tools meant babysitting this fragile, messy tangle of custom, model-specific wires. Every time an API updated, boom, your bindings broke. Every new tool meant writing brand new integration code. It was totally exhausting. But with MCP, the agent just holds this one single plug.
And here's how elegantly this works in practice. Step 1, your agent is ready with its universal plug. Step 2, your external platforms extend matching, standardized MCP sockets. And Step 3, the agent just plugs in. It seamlessly connects over standard input/output or HTTP to absolutely any platform providing that socket. No complicated handshake, no fragile integration layers, just an instant, standard connection.
Now let's talk about connecting those external enterprise sockets for instant capability with zero bloat.
When we look at the server side, you can see what these sockets actually unlock in the real world. Imagine you've got a complex task, and your agent needs to orchestrate a fix across your entire stack. It can instantly connect to GitHub to extract a bug report, reach right into Jira to grab the exact acceptance criteria, and then plug directly into your local Postgres database to inspect the schema it needs to write an optimized SQL query. And it's doing all of this using one universal standard, without you writing a single line of custom integration code.
The very moment the agent plugs in, these structured resources are available on demand. But here's the genius part. It uses a concept called progressive disclosure. The agent only requests the specific data it needs exactly when it needs it.
Think about the old way, where we just dumped the whole schema into the prompt just in case. Now it doesn't ask for the entire database. It just asks the Postgres socket for the specific table names it's working with right now. It queries step by step, keeping its memory completely free of clutter.
Which leads us to maybe the biggest win of all: zero custom API wrappers and programmatic tool execution.
This quote straight from the architecture docs perfectly captures the power of that plug metaphor. Decouples tool interfaces from agent models. This should be a massive light bulb moment for any engineer listening. It means you are finally done writing custom API wrappers for every single tool in your stack. You don't have to go in and patch the model's logic every time Jira decides to update its API. The MCP server handles all that translation for you.
Let's really break down this shift. The old way relied heavily on custom binding code and these repetitive, natural language round trips. Every time the agent queried a tool, massive raw JSON payloads were dumped straight into the chat history. The model had to literally read all that raw data, leading straight to token exhaustion. But the new way, using standardized MCP sockets, allows for programmatic tool execution. This is brilliant. The data is filtered programmatically inside a local sandbox. The agent writes a quick script to query the database, the sandbox runs it, filters out all the noise, and only returns the refined, highly specific answer to the agent's main conversation. All the heavy lifting happens in the sandbox, not in your prompt.
All of this results in light, fast, modular memory that actively protects your context window.
Ultimately, MCP completely flips the operational paradigm for autonomous terminal native engineering. Because you're using progressive disclosure, decoupled interfaces, and programmatic execution, the agent's active reasoning context stays perfectly unpolluted. It stays fast, it stays incredibly performant. The AI isn't burning its precious thinking budget trying to read 10,000 lines of irrelevant API logs. It gets to use every single token to actually reason through and solve your toughest architectural problems.
So, I'll leave you with this thought as we wrap up this explainer. As you start scaling multi-agent deployments across your entire organization, how are you going to protect their cognitive bandwidth? Are you going to keep hard-coding those fragile API wrappers that break with every single update? Or is it finally time to give your enterprise agent the universal plug? Thanks for exploring this massive architectural shift with me. Catch you next time.